Alright everybody, welcome back. In this video we're going to be handling concepts from section 6.5 of AP Calculus, interpreting the behavior of accumulation functions involving area. We've already done one video on this topic. This is going to be the second one, and in this video we're just going to work our way through two example problems from old AP exams involving the concept. So here we go. Without any further ado, example 2. This is free response question number 4, which is a non-calculator question from the 2021 AP Calculus AB exam. It opens with, let's let f be a continuous function defined on the closed interval from -4 to 6. The graph of f, consisting of 4 line segments, is shown below. We see it here. We're told that capital G is the function defined as the integral from 0 to x of f of t dt, which means that capital G prime of x is equal to f of x using the fundamental theorem of calculus. So this is not only a graph of lowercase f, this is also a graph of G prime. All right. So let's go about answering these questions. Part A, on what open intervals is the graph of capital G concave up? Okay, since this is G prime, that means we want G prime to be increasing in order for G to be concave up. So we want the slope of G to be positive. So that happens on the interval from -4 to -2, and from 2 to 6. And as far as a reason for my answer, the graph of f, which equals G prime, capital G prime, has a positive slope here. Meaning G prime, or G double prime, is greater than 0. Some kind of explanation like that. All right, part B. Let capital P be the function defined by capital P of x equals capital G of x times f of x. Find P prime of 3. So the first thing we're going to do is find this derivative in general. P prime of x is equal to, and we need to use the product rule here, G times f prime of x plus f times G prime of x. And then we can utilize the fact that G prime is equal to f, and this is really G of x times f prime of x plus f of x times f of x. Okay, so we want to find this for, we want to find P prime of 3. So we're just going to go ahead and substitute 3 in here everywhere where there's an x. From the graph of f, I can read that the function value at 3 is -3. So this is going to be plus -3 times -3. I can read that the derivative f prime at 3 is the slope of this segment. So that's going to be 1. And then capital G of 3, from this statement up here, capital G of 3 is equal to the integral from 0 to 3 of f of t dt. So that's the area that I'm accumulating from 0 over to 3. If I look at this, I've got a positive 2 from this region right here. And then here we've got, let's see, we've got a -2 from 1 to 2. And we've got a -3.5 from 2 to 3. And therefore the value of this is going to be -3.5. And doing all of our calculations, 9 minus 3.5 is 5.5. So that's our value for P prime of 3. All right. Next, find the limit as x approaches 2 of g of x over x squared minus 2x. G of 2 is the integral from 0 to 2, which we just showed there's a positive 2 and a -2, so G of 2 here is 0. 2 squared minus 2 times 2, also 0. So this is a 0 over 0 indeterminate form. So we're going to apply L'Hopital's rule. And so the limit as x goes to 2 of capital G of x over x squared minus 2x is equal to the limit as x goes to 2 of capital G prime of x over 2x minus 2. So that's G prime of 2 over 4 minus 2 is 2. And G prime of 2 is equal to the value of f of 2, which we can read from the graph. It's right here. F of 2 is negative 4. So this is negative 4 over 2. And the value of that limit is going to be negative 2. And then the last part, find the average rate of change of G on the interval from negative 4 to 2. Does the mean value theorem guarantee a value C for which G prime of C is equal to this average rate of change? Justify your answer. All right, so the average rate of change of G, that's going to be capital G of 2 minus capital G of negative 4, all over 2 minus negative 4. We already said G of 2 is 0. G of negative 4 we need to calculate, and that is going to be based off of the area under here. But all of that area, I scribbled a little far to the right there, from 0 to 4. All of that area, since we're accumulating backwards, is going to be negative area. But let's see what we've got here. We've got a rectangle down here with an area of 8. That's 8 units right there. We've got a triangle right here with an area of 6. 1/2 times base times height, and we've got a triangle here with an area of 2, so it looks like 16 is the value of G of negative 4. So this is negative 8/3. Does the mean value theorem guarantee a value such that for which G prime of C is equal to this average rate of change? Yes. G of x is continuous, since it's the integral of f of t, which is a continuous function. It says it up here. G of x is continuous and differentiable. On negative 4 to 2. So f prime, or capital G prime of C, must equal negative 8/3 somewhere in that interval. All right, gotta keep plugging. I've got a little bit less time for our second example here. This is example 3. Free response question number 3, again a non-calculator question, this one time from 2014. Again, we've got the function f defined in a graph. Graph consists of 3 line segments shown in the figure below. Let g be the function defined by g of x equals the integral from negative 3 to x of f of t dt. First find g of 3. So that's going to be the integral from negative 3 to 3 of our function f from the graph. So from negative 3 over to 3. We've got this area up here, 1, 2, 3, 4, 5 for the base, 4 for the height. So that's 1/2 times 5 times 4 minus 1/2 times 1 times 2 for that triangle. And so that gives us 10 minus 1, or 9 for the value of our interval. Part B, on what open intervals contained in the graph is the graph of G both increasing and concave down? So in order to be increasing and concave down for G, that means that G prime must be greater than 0 and G double prime must be less than 0. Well, since g of x is equal to this, that means that g prime is equal to f of x. So this is a graph of f, also the graph of g prime. So we're looking for places where g prime is positive to meet this characteristic, but where g double prime is negative. And where g double prime is negative is going to be where the slope of this graph is negative. And so we've got our intervals. We've got from -5 to -3 right here, and we've got from 0 to 2. Okay, f equals g prime is greater than 0 on these intervals, so g is increasing. And the slope of f, which is g double prime, is less than 0 on these intervals. So g is concave down. Okay. Part C, the function h is defined by h of x equals g of x over 5x. Find h prime of 3. So we're going to go ahead and take the derivative, h prime of x. I'm going to use my quotient rule here, low times the derivative of high, minus high times the derivative of low, square the bottom, and away I go. So h prime of 3 is going to be 15g prime of 3 minus 5g of 3 all over 9 times 25 is 225. So we need g prime, which we get from the graph. G prime of 3 is the y value there. That's -2. That's 15 times -2 minus 5 times. And then g of 3 we found in part A. That was 9. So we're going to go ahead and put 9 in here. And that gives us, looks like -30 minus 45, -75 over 225, or -1/3 for the value of h prime of 3. All right, and then the last part here, the function p is defined by p of x equals f of the quantity x squared minus x. Find the slope of the line tangent to the graph of p at the point where x equals -1. That's just going to be the value of the derivative of p when x is -1. So I take the derivative of p prime of x is equal to, and I need to use the chain rule to take the derivative of this, derivative of the outside, leaving the inside the same, times the derivative of the inside. And then we're going to substitute -1 in here. So p prime of -1 is going to be f prime of -1 squared minus -1 times the quantity 2 times -1 minus 1. So that makes it f prime of 1 plus 1 is 2. F prime of 2 times -3. Then f prime of 2, since this is the graph of f prime of 2 is the slope of this line segment right here, since it goes through where x is 2. Slope of that line segment is -2. And so this is going to be equal to -2 times -3, or 6. All right, that takes us to the end of that example and the end of the lesson, and in fact the end of the section. There's going to be some practice problems for you to do. Go ahead and do those as well as your MyAP assignment, and we'll see you next time in section 6.6 coming up. All right, everybody, have a good rest of your day. See you next time.